Okay, so third mini lecture for this period of October, it was November 16th to 20th, so the week after Reading Week. Third mini lecture is, so let me just take you back here. So we ended off with this, thinking about property and the economics of innovation. Now I want to, kind of capping off a discussion about the technical basis for development of new innovation and its use in the areas of herbicides, insecticides, and plant breeding in particular. And here we're going to see how some of these things kind of come together and real controversies about these. And so we're going to use the case of glyphosate and other herbicide resistance crops in North America. So I talked about the discovery of glyphosate by the Monsanto company. Here is a graph which shows from 1992 to 2014 the amount of glyphosate which was used, and you basically see a linear upward trend in the amount used, to today, to 2014, but beyond till today, as the use of glyphosate has risen, especially since, so the Monsanto patent came off in the year 2000. Since then, other companies are also producing. We can see the red line there shows the price, and you can see how Monsanto was maintaining quite a high price up until the year 2000, and then brought the price down, and that price has remained lower and generally gone lower through more competition with other companies. So you can imagine, in a way, how the profits that Monsanto made during those early years when they had the patent. But it's interesting that most of the use of glyphosate has actually been since the patent has come off, although we still mostly associate glyphosate with the Monsanto company. One of the challenges that develops when you have reliance on a single type of insecticide or other chemical is that as plants adapt and mutate to the environment, an environment in which we have glyphosate being used, then that could become less effective over time. This shows a graph of the number of resistant weeds that have developed over time, relatively small compared to the use of glyphosate. So yes, there has been some development of resistance among the target weed populations, but perhaps less than had been expected. And really any new chemical will have this. So this really it's a disadvantage of any reliance on any chemical, not necessarily a particular unique feature of glyphosate. Here's a sort of a key issue about glyphosate is how the Monsanto company kind of brought together different technologies. So we have on the right side, this is Roundup or glyphosate, which is used to kill weeds. On the left side, you can see the symbol for Roundup Ready. So this is Roundup Ready crops have been developed by plant breeding and have been through transgenics to be resistant to glyphosate. So it means if you plant a crop, it's resistant to glyphosate even when it's growing and all the weeds are growing. You can spray the glyphosate on top. The crop will remain because it is resistant to the glyphosate. All the other weeds will die, right? So it's a very, very effective way at controlling the agricultural environment that allows you to kind of pack things in time and space, right? So by combining glyphosate with a glyphosate resistant crops, you really are kind of do a double effect on your weeds. Monsanto, so they had lots of incentive to develop that glyphosate resistant crop. They developed it in 1996. It was quickly, as I said, as I show here, by the year 2005, covered most soybean fields, for example, in the United States. So people reacted very, very quickly to glyphosate-resistant crops, and it took over. So that kind of solidified Monsanto's claim to this space of glyphosate and glyphosate-resistant crops, having the patents on both of these. It meant more glyphosate could be used for weed control, so that we sort of expanded the demand for glyphosate, and meant that you could have higher yield through less competition with weeds, less need for tillage, really quite a game changer in agricultural operations. We call that HR, so herbicide resistant, but the main herbicide that resistance has been developed for is for glyphosate. Another class of transgenic crops is insect-resistant crops. So this uses a bacterium called that's described there, Bacillus thuringiensis, or BT. So I'll just use BT from now on. So the bacterium BT produces a toxin naturally, and there have been attempts to try to use that toxin as what we call a biological control. So basically a natural control for insects. And in 1996, scientists developed a transgenic approach to insert this BT gene from the BT bacterium into crops. The result is that there's less insect damage to crops, which is good. So the crop is growing, it's naturally resistant to the insect does less damage to it. It also reduces the use of other things that you would use to get rid of insects. So as I said, we just developed all of these, over 100 different compounds to try to kill insects in the periods of the 1940s to 1960s, including DDT, which had all of its harmful effects. So developing something where you could actually build the resistant to the insect right into the plant is a great advantage. So these are the two big ones. The two big transgenic crops which have been adopted at large scale are herbicide-resistant varieties and insect-resistant varieties. There's a few other things other than BT. There's also there's something called the rainbow papaya that was developed by scientists at Cornell University for this context in Hawaii. And that is this variety of transgenic papaya is resistant to a virus that was wiping out at that time, the papaya crop of Hawaii. So we've got other examples of insect-resistant crops, but the scale at which they're adopted is much different. Okay. So this shows the adoption of the BT, so the insect-resistant corn and cotton, and the herbicide-resistant varieties of corn, cotton, and soybeans. You can see how we went from, like 10% adoption in 1996 to up over 80% adoption in all of these crops by 2016. So these are really taken over in the United States and Canada to a little bit less extent, less so in other parts of the world. And we'll talk about that in a while, but certainly in Canada, US. We can see here also that has been more recently adopted in Brazil. And so now Brazil is the biggest user in terms of the percentage of arable land which is planted with GM crops. So this is genetically modified crops. And as I said, that's mostly herbicide resistant and insect resistant crops. Brazil now has greater percentage of the area planted to those crops than the US. China and India are much lower, as is the European Union. So only about 12 to 15% of the world crops is planted with is GM. Okay, so the debate. So this is something large scale in the U.S. particularly. Let's focus on glyphosate. kills a variety of weeds, so it's this, and including perennial weeds, which are hard to get rid of. It is applied directly to growing plant tissue, inhibiting the growth of a weed as it's growing. You don't have to have it work in the soil, so it's applied to the growing crop, the growing plant. Therefore, there's less residue of it in the soil. It doesn't cause much, if any, harm to non-target plants and animals, as long as it's carefully applied. Glyphosate is also used here in Canada as a desiccant, or something which reduces water content in the fall, so that canola can be harvested sooner. So lots of advantages. Disadvantages include health effects, and I'll talk about that in more detail in the next lecture. That was a big focus in the next mini lecture. You have to take care when you're applying it to make sure that it really goes on the plant that you want it to impact, but not other plants. There has been some resistance developed, as I said, although perhaps not any more than any other chemical. It's expensive. People spend a lot of money on glyphosate. The question is how expensive, and that is sort of the issue of the counterfactual. And then the other point that people see as a disadvantage is having Monsanto be kind of the developer and holder and seller of glyphosate and glyphosate resistant crops gives them this big sway over our agriculture. And people have come to see Monsanto as sort of the example of the kind of big profit-driven agriculture enterprise, which does not care very much about the human or the environmental effects of its technologies, as long as it can dominate and make money. So if we're thinking about, is glyphosate good or not? At least for the United States, it would be hard for us to know what the world would be without it. But we would be challenged to think about what's the counterfactual. For example, would other herbicides be used if this wasn't being used? And if they were, which is almost certainly, would they be better or worse? They mostly would be worse. What else would farmers be doing to control weeds? So they used to have to use cultivation and tillage to control weeds. So would they return to that? If they return to more tillage, probably have greater greenhouse gas emissions because they would use more energy. Tillage also damages soil organic matter. We've talked about the importance of soil carbon. And they may well have to be farming larger areas for the same output. So that's thinking about this, the kind of Borlaug hypothesis here. So this is something we'll get into in a minute, but here I wanted to kind of establish this kind of debate and the issue of the counterfactual. So I'm going to stop this mini lecture here. I'm going to try.